Welcome to this video in the atomic theory unit. This is atomic structure and the periodic table. In this video, we're going to explore the atom and learn how to use the periodic table to do a large laundry list of things. We're going to learn how to determine the number of protons and electrons in an atom, determine its mass number, calculate the number of neutrons, write some isotope notation, differentiate between atoms and ions, determine the number of electrons in any ion, and predict an ion's charge using the periodic table. If you haven't already done so, please make sure you have downloaded and printed your companion worksheet and you have your chemistry notebook handy in order to take some notes. You are also going to need this bad boy over here, your periodic table, so make sure that is downloaded and printed as well. So without any further ado, let's get started. Leading off this video, we probably should begin by talking about the general structure of an atom. And if you recall the atomic history video, we've already discussed the discovery of all of the subatomic particles. But if you haven't seen that yet, let's just give you a quick primer here. Your atom is going to have two primary regions of interest. There is going to be the outside of the atom, which is over here. That is your electron cloud. And then there is the inside, which is your nucleus. Now, within each region that we see here, there are specific subatomic particles that make it up and specific facts that we should probably put in our pockets for later. Let's dive in. So first, let's start talking about the nucleus. Essentially, the nucleus is a small and dense positively charged region at the center of the atom. Our nucleus contains two subatomic particles. They are your protons and your neutrons. New vocabulary word for you. Protons and neutrons are collectively known as nucleons. And fun fact, virtually all the atom's mass is going to be found in the nucleus. So like 99.9999999% of what the mass of an atom is all protons and neutrons. Moving to the outside of the atom, we have the electron cloud. Instead of two subatomic particles, out in the electron cloud, there is only one, and it is your electron. The cloud makes up all the volume of the atom. So this is an important distinction to make, that the nucleus makes up all the mass, yet the cloud makes up all the size or the volume of the atom. It is indeed mostly empty space because remember there are great distances between the electron principal energy levels. If you're coming from bio, remember those are your shells or your rings. And fun fact, which will be really important in the periodic table chapter, electrons are responsible for all the chemical properties of an atom, and that means its behavior. Diving in a little further into the three subatomic particles, we're going to talk a little bit now about the electron. The symbol of an electron will be shorthand an E with a negative sign here. Its charge is going to be -1, and its relative mass is going to be 1/1840th the mass of a proton. You'll see here it says relative mass in AMU, and AMU is an atomic mass unit. Remember, these atoms and these subatomic particles are incredibly small, so we needed a unit to use with them that would make some sense, and we couldn't really use grams because the atom is way smaller than a gram, where you would get numbers that were just ridiculously long decimal. So scientists came up with atomic mass units, which are essentially 1/12 the mass of one carbon atom. It's based off the carbon standard. Our proton is the symbol P with a little superscript plus on there, and it is a +1 charge. It is as positive as the electron is negative. And what's nice about the proton, it is one atomic mass unit. The neutron, it is going to have the symbol N with a superscript 0 because it has no charge, which we see here. But even though it has no charge, it has the same mass, or virtually the same mass, as a proton. So remember, when we say all the mass of the atom is made up of protons and neutrons, this is why, because electrons have virtually no mass. Now that we've got an introduction and some background out of the way, let's start to talk about what the periodic table can tell us about the structure of an atom. So this is your time. You guys need to now have your periodic table of elements handy because we are going to be using it for just about every part of this segment. First things first, What is an atom's net charge? Well, I'm not sure if you remember this from middle school, but all atoms are neutral. In fact, most of all matter is neutral. Typically, atoms will carry a neutral charge, and that means it's neither positive or negative. And why that is because here you can see the number of protons is equal to the number of electrons. And since both carry a charge of +1 and -1 respectively, they cancel one another out, and we get something called electroneutrality. So it is that 1-to-1 proton to electron ratio that results in having every atom be neutral. Since we just made mention about protons, we probably should teach you how to figure out how many protons are in any given atom. Well, what you guys need to do is we need to look at the atomic number, which are these numbers that are right there. On your periodic table, they are always going to tell us the number of protons in any atom, doesn't matter which one it is. It will also tell us what is known as the nuclear charge. Think about that. The only thing in the nucleus with a charge are your protons, because the other particle that's in there are neutrons, and they are neutral. So because each proton carries a charge of +1, let's just look at, let's say, chlorine down here. The nuclear charge of chlorine would be +17. Important. The nuclear charge of nitrogen would be +7. Protons also determine the identity of the atom. Because no two different elements have the same number of protons, it is the differentiating feature of an atom. So you will notice that your periodic table is arranged sequentially by ascending atomic number, and each element that is on that periodic table will have a different atomic number and number of protons. All right, now it is your turn. Stop the video, and for these 3 elements that are here, use the periodic table and tell me how many protons there are in these atoms. When you're finished, unpause the video and check your answer. All right, if you did that correctly, here are your answers. Nice job. Our next segment here is to talk about how many electrons in an atom. And if you remember that we just talked about, atoms are neutral, so electrons have to be equal to the number of protons in an atom. So what we do is, if I wanted to say how many electrons in something like nitrogen, well, because the atomic number is 7, that means we would have 7 protons. We will also have to have 7 electrons. Otherwise, our nitrogen atoms would not be neutral. Same with chlorine. Because we have 17 protons, our chlorine atom needs to be neutral. So we would have 17 electrons. Stop the video now and tell me how many electrons in these 3 atoms. And indeed, you hopefully were correct. There are 37, 28, and 32 respectively, equal to the atomic number. 2 more nuggets of information that we need to know deal with the mass number and the number of neutrons in an atom. Let's talk about neutrons first. Neutrons is not definable by just looking at your box here, but you can use some information that's in your box in order to figure out how many neutrons we have. Specifically, we need to look at something called the mass number. You will look at your periodic table and you will say, well, there's an atomic mass, but I don't see a mass number. In order to get the mass number, what we have to do is we have to round the atomic mass to a whole number. So for instance, in the case of nitrogen, which is right here, if I have an atomic mass of 14.0067, my mass number is 14. In chlorine, since my atomic mass is 35.453, I will have a mass number of 35. Since we now know the mass number, in order to find the number of neutrons, all we simply need to do is subtract the atomic number or the number of protons from the mass number, and that tells us the number of neutrons. So, examples. Let's say nitrogen 14 has 7 neutrons. How did we get that? Well, the mass number of nitrogen is 14, and if I take away the atomic number, which is 7 here, that's going to get me 7 neutrons. So you can almost look at the numbers that are here and say 14 minus 7 gives you 7. In this case, 35 minus 17 would get you 18 neutrons for chlorine. Piece of cake. So you know what it is. It's your turn now. Stop the video and do some calculations. Figure out the mass number for each one of these atoms and then figure out how many neutrons there are. Unpause the video when you have your answers. All right, if you did it correctly, here is what you should get. Remember, if you find anything unclear, make a note of it because we can certainly talk about it when we convene in our next session. While we were busy talking about neutrons and mass number, I wanted to give you an alternative calculation that you might find helpful. Mass number for an atom can also be calculated by adding the number of protons and neutrons together. So let's say you have an atom that has 7 protons and you have 7 neutrons. That would give you a mass number of 14. This is really helpful when you start to get into atoms that have isotopes. And if you remember what an isotope is, that is an atom with a different number of neutrons but the same number of protons. So for instance, let's say we may have one day an isotope of nitrogen. It's still going to have 7 protons, but it may have 8 neutrons, which would give us a mass number of 15. Now you'll notice that the mass number of 15 is different than the atomic mass, which is listed here on the periodic table. So this calculation is super helpful once we get deeper into the atomic structure unit. While we're here, it is also probably a good time to teach you guys about something called isotope notation. And what isotope notation is a shorthand way of expressing the mass number and the atomic number. So let's take sodium, which is here. We know sodium has an atomic mass of 22.98977 and 11 protons. Well, isotope notation takes this information, turns this into a mass number, and then writes it in this format that we see here. We have the mass number of 23 put over the atomic number of 11. And you will see those sometimes in some textbooks represented with the mass number with an A and the atomic number or the charge of the atom's nucleus with a Z. Another way you can see this written is sodium 23, where they actually list the entire name of the element along with its mass number. So do not be surprised if you ever come across these things. It is just other ways of expressing information for an atom. The last stop in our video is all about what happens when atoms stop being neutral and form ions. By definition, an ion is any atom or group of atoms that will bear one or more positive or negative electrical charges. So how does an atom become an ion? Well, essentially, an atom becomes an ion when the number of protons and electrons is no longer equal. Remember, coming off the assembly line at the atom factory, all of your atoms are going to have the same number of protons and electrons. But something happens to foul up that beautiful balance that we have there. And what actually happens is those atoms will engage in a chemical reaction, and that is what causes them to gain or lose electrons. What that will do is shift that particular atom's neutral charge towards either now a positive or more negative charge, thus creating the ion. So the skill that we have to learn is how to predict the number of electrons that there are in an ion. And the key to that is looking at something called the oxidation number. If you look at your periodic table, the oxidation number is this value, or you can notice here for nitrogen, values that fall on the upper right-hand corner and get listed downward. What's cool about that is the first value that is listed tells us the most common ionic form. You'll notice that for sodium and for strontium down here, there's only one value. So that means it only forms one type of ion. But something like, let's say, nitrogen or chlorine tends to form multiple kinds of ions. Most commonly, the nitrogen ion, or the nitride ion as we're going to call it, winds up being the -3 form. The most common form of the chloride ion is the -1 form. Why are the rest of these listed? Well, it's because it is possible for these atoms to turn into ions that actually do carry that value of charge, but most commonly we are going to see the one in the first. So if we came across, let's say here, we came across a sodium ion, we know that that will lose one electron to become more positive. We know that sodium, when it is neutral, has 11 electrons because the atomic number equals the number of protons, which should equal the number of electrons. Well, if it became a sodium plus 1 ion, that means it lost 1 electron to become more positive. Remember, if you have 11 protons and then you lost an electron, you go from having 11 electrons to now having 10 electrons. So you have 11 things that are plus, 10 things that are minus. That gives you a net charge of plus 1, and that is why it is a plus 1 ion. That forms, here's some vocabulary for you, a cation. Not a cation. A cation is a positive ion. Take something like chlorine. It's going to, as we see here, turn into a negative ion, which means it's going to gain 1 electron. So think about that. Remember, when it comes off the assembly line, there are 17 protons and 17 electrons. But in order to become a negative 1 ion, it's got to pick up an extra electron. So now it's going to have 18 electrons, which is going to give it a net charge of minus 1. A negative ion is known as an anion, not an anion. So now it is your turn. This is probably the most important skill that we have in this video. See if you can put it all together and determine how many electrons in the most common form of these ions. Now remember, some have multiple oxidation states, but remember how to differentiate what the most common form is. So pause the video, figure out how many electrons an ion would have, and then unpause the video and check your answers. All right, here are your answers. Make sure you did the work correctly. Remember, if you are going to become a positive ion, you will be losing electrons. If you are going to become a negative ion, you will be gaining electrons. If you did indeed have any miscues, get anything wrong, or there's just something that you don't understand, please do not hesitate to bring it up during the burning questions segment tomorrow, where we can fix anything that is ailing you. It's been a pleasure taking you through the early parts of atomic structure in the periodic table. Gonna see you guys on the flip side. Peace out.
That's all, folks.